we'd like to verify that this equation is in fact an identity. It doesn't much matter which side I start on, the left or the right. They kind of look similar in complexity, so I'm going to take the left and see if I can make it into what's on the right. In the numerator here, I have secant squared x minus 1, and one of those Pythagorean identities says tangent squared x plus 1 equals secant squared x, which means secant squared x minus 1 is tangent squared x. So we'll make that substitution. Now I have tangent squared x over sine x. Okay, well, so I have a tangent squared and a sine, and I'm aiming for something that has all sines in it. So I'm going to have to do something about this tangent squared that makes it into sines. I'm going to use a quotient identity, namely that tangent is sine over cosine, so tangent squared is sine squared x over cosine squared x. And that's all over sine x. So that sine x is in the denominator, and it's going to stay there. So here's my tangent squared x. And here's my over sine x, 1 over sine x. Well, okay, that's maybe better. And now I'm going to notice that I have a sign on the top and a sign on the bottom. We're allowed to use algebra. So let's divide one of those away. And now I have sine x over cosine squared x. Well, the numerator matches what I want. That's a good sign. Maybe I'm heading in the right direction. But the denominator does not. However, that cosine, let's go for purple. That cosine squared x, we have another Pythagorean identity that says sine squared x plus cosine squared x equals 1. Which means cosine squared x I can get by subtracting sine squared x. That's 1 minus sine squared x. So that now I have sine x on the top, and we'll swap out cosine squared x for 1 minus sine squared x, and we did it. That's what we were aiming for. So we took the left-hand side, turned it into the right-hand side, and showed that this is, in fact, an identity.